Hey everybody, it's Mike from GrowersHouse.com, and I'm here today because I wanted to share with you guys a couple of tips, tricks, best practices when it comes to applying mineral nutrition or applying your fertilizers to your media, to your plants. I see a lot of misconceptions out there. Everyone's obsessed with plant steering. I think it's important for us to remember what the fundamentals are when it comes to a good fertigation and good fertilizer application program, and base all of our decisions on good practices initially, and then tweak those to improve our grow, do the plant steering after we have our irrigation program kind of set as a very good standard. So one big thing that I get a lot of questions about is adjusting feed rates. A lot of the feed charts out there for particular nutrient brands are going to be like a single rate throughout the entire cycle. So generally in a nutrition program, we're looking at about 2 to 3 phases of different ppm delivery throughout that growth cycle. You could be fine with one, but generally what's gonna happen is you're gonna be in excess of a lot of the stuff that you don't need in late flower. And in early flower, you might be at a little bit of a deficiency in certain things, because if it's one program that's good for the beginning of your flowering stage and the end of your flowering stage, it might not be covering the bases on all of those stages. So in addition to having a variable feed rate, we also recognize that the facility design plays a lot into how that feed rate can change. If you're running just Dosatrons, generally you're not going to be able to just constantly change your dosing rates on the fly. Moreover, you don't really want to on a Dosatron. Dosatrons are really good at kind of a set it and forget it type of a run. So a lot of guys on Dosatron systems that want the modularity of changing your delivery ppms throughout the cycle, they'll actually have multiple runs of Dosatrons, each one creating a different formulation for a different part in that growth cycle. So when it comes to nutrients like VPS or any of the more science-backed, more modern nutrients, they're going to want you to run like a changing or a differing ppm delivery in your early cycle and your late cycle especially. And if you have the ability, like if you're using like a pneumatic pumper system where you can kind of adjust your rates, or if you're using an electronic system where you can adjust your rates on the fly, then it's really nice to be able to have multiple stages of growth so you can target exactly what your plants are going to need and want in those stages of growth. So in addition to your ppm delivery changing ideally throughout different phases of your growth, one of the other things that you're going to have to play with is the actual EC of the water that you're delivering. How much dissolved solids, how many ppm of nutrients is in that water. The type of media that you use plays a big role in what your target ECs are generally going to be. So a lot of us are used to seeing things like Stonewool, Coco, and of course then there's soils. Soils is going to be a lot trickier because of the composition of the soil. A lot of that stuff, a lot of the times, even in a high EC setting, it's not really plant available. They're just salts in the actual media in the soil. So even though the runoff may be high, it might not be that plant available. In those situations, it's really important to make sure that you have a high amount of water in there so the plant can selectively choose what ions it wants to take, because there's just so much in that soil already. Now in a Coco and a Stonewool setting, we are basically creating that soil for the plant. In a Stonewool setting, it's pretty easy. It's very porous. There's not a lot of CEC sites there. There's not a lot of nutrient holding capacity in a Stonewool. So generally what we're looking to do as far as EC and applying fertilizers is we want to be consistent, because what we're doing actually is not just adding nutrients and water to that media brick. On that Stonewool brick, what we're doing is we're replacing that soil solution as thoroughly as possible and as regularly as possible as the plant requires. Obviously, you're going to want Drybacks, but the Dryback percentages are going to be a little bit less on a Stonewool, because generally you want to keep those Stonewools a little bit more saturated than like a Coco or a soil. So in Stonewool media, your EC requirements are going to vary anywhere from like your runoff readings will be like anywhere from 3 to maybe all the way up to 6, sometimes even 7. Generally, you want to stay under that 7 range in Stonewool, and you want to make sure you're getting good root zone solution exchange every time that you irrigate. So for Stonewool, that big consideration is making sure that you're using the correct volume at the EC that you intend to deliver, such that your root zone stays within that 3 to 6 range while still maintaining a water capacity of roughly over 35, around 45% minimum. So Stonewool, it's a very pure hydroponic type of media. You're getting that hydroponic solution in, the plant uses what it needs, it gets the water that it needs, it slowly dries back to get oxygen to the roots, and then you're replacing that soil solution with a fresh batch of nutrients so that the plant can utilize what it needs, drain off what it doesn't, and then the cycle repeats itself. Very uniform, very easy to run Stonewool. Things like Coco, that's when you really have to have a lot of considerations in your prep, as well as in the later stages of the accumulation of nutrients in the root zone. So for Coco, depending on the type of coco coir you run, whether it's just a washed or if it's a buffer, you're going to want to pre-treat the coco coir a certain way. Generally, what we recommend is if it's just a purely washed, like a triple, double, however many times washed to be inert, if you hydrate one of these bags and the runoff on that hydration reads close to 0, less than 0.4, then you can be pretty sure that this is a pretty inert, got nothing in it bag, which also means you have tons of CEC sites, tons of sites within the media where nutrient ions can stick to, and a lot of the times they stick there and they're kind of there. They're filling those slots and they don't easily break off. So what we want to do initially when we start hydrating these bags is to load these washed cocoa bags with a nutrient solution that we expect a transplant or a young plant to want. So it's going to be higher in nitrogen, higher in calcium, magnesium. It's going to have good micros, good level of phosphorus in there as well to get that new growth going. Additionally though, we're going to want to fill the CEC sites with more calcium and magnesium ions. Now, if you're using a program like the Ventana Plant Science program, it's kind of nice because they have the calcium nitrate and the magnesium sulfate separate. So you simply just have to increase the rates of those two salts for your initial loading phase. Generally, you'd want to use like a very robust veg formulation or like an early veg formulation amended with more calcium nitrate and more magnesium sulfate. That's going to ensure that the positively charged ions, calcium and magnesium, fill the sites, potentially displace a little bit of sodium that might be left over in the cocoa, and make sure that this cocoa is ready to plant and isn't going to basically starve the plant during its initial first few days in the media. So what we're doing with cocoa is we're basically creating our own soil off of an inert substrate and the nutrients that we choose to apply. So now that we have our high CalMag base formula for veg watered into these pots and they've been saturated 100%, then I can be basically assured that when I transplant into these pots, I'm not going to get any huge transplant shock. And the EC of that plug cube that's been around for about 2 weeks is generally going to be about the same, about a 2, as the root zone itself, a 2 to a 3. And that EC similarity between the plug and the actual transplanting bag is going to help reduce your transplant shock and get those roots going and get that plant growing as fast as possible. Now, how do you measure what the runoff is? You know, this is where something as simple as a saucer and a pot riser come in extremely important. You know, in the hydroponic world for fruit, you know, they always do lysimeter readings to find out how much water they're putting down, what the EC and pH of that water is, how it compares to the EC and pH of the table or the trays so that they can adjust their nutrient profiling. This is similar in respect to adjusting the nutrient profiling and getting that metric, getting those data points so that you can build out kind of a history of how your plants do and what those parameters were when they were doing well. So now that we have our media, it's fully saturated, we got a plant in here, we have our drip stakes in here, it's come to full saturation and we're starting to get a little bit of runoff. Generally, what I recommend people when it comes to runoff on a cocoa cube, you're gonna want anywhere from about 8 to about 15% runoff. It can go higher, but the problem with going higher is you're using quite a bit of water and nutrients to do so. It takes quite a bit more water to get a cocoa block saturated and watered through than it does, say, a Stonewool block. So say this Rockwool cube is fully saturated, it's got a little bit, maybe 10% of runoff out of it. What I'm going to do at that point, and the irrigation has stopped, what I'm going to do at that point is I'm going to have my crew come in, they're going to lift the pot, they're going to pour the contents of the saucer into a measuring cup, they're going to get the volume, they're going to get the EC, and they're going to get the pH of that solution. Now the volume is going to tell us a couple of things. The volume is going to tell us, yes, we're at full saturation and we had runoff. The volume is also going to tell you, hey, this is not enough water or this is too much water. If your runoff percentage, say you're applying 1,000 mils of water and your runoff is 200 mils, that's 20%, you're on the high side. So that way you can know on the next subsequent waterings, hey, I'll bring it down 900 mils. And then we'll see what the runoff is. And then, hey, we'll bring it down 800 mils, see where the runoff is. At 800 mils, we're getting consistent 8 to 15% runoff. Then we know 800 mils is what we target on a daily watering. So getting these metrics, gathering that data on your runoff allows you to kind of plan ahead and understand exactly what your plants are needing in each specific stage of growth, which is really important if you want to forecast costs, forecast out how your business is going to do or how your grow is going to do based on the inputs that you're required to put down. So when it comes to Rockwool, you know, it's going to be basically the same. You can have a saucer set up like this. Obviously, you want to size them to the pot so that they're not taking up too much of your bench space. But with Rockwool, you're going to do the same thing. You're going to have your drippers in there. Last irrigation event of the day, you're going to check your runoff, check the volume, you're going to check the EC, and you're going to check the pH. That way you can use the volume to determine if you need to increase or decrease the volume that you deliver. You can look at the EC to determine whether or not you need to increase or decrease your EC. Because if your EC on your runoff after a few weeks of growth in a Stonewool cube is still coming out very close to your delivery EC, you're getting very little stacking in the pot. So what you can do is possibly increase the EC of what you deliver so that your plants can get as much nutrients as they would need and there's no bottlenecking factors in the nutrient delivery. And at the same time, you don't really run the risk of stacking the EC in your root zone so high because you're getting good root zone soil solution turnover. When it comes to Stonewool, you're gonna find that it's gonna be a lot easier to affect that runoff EC because it has such little capacity to hold the nutrients in the cube itself. So say you're running Stonewool and you have an EC of like 2.5 and you're watering in about 2.4, 2.5, then looking at the volume, if your volume looks like it's right at where you need it to be for Stonewool, where a runoff event is probably gonna be anywhere from 10 to 20%. If you're within that 10 to 20% runoff on that Stonewool, but the EC of the root zone stays low, then you can increase your delivery EC. Now, alternately, if you're watering your plants in Stonewool and that runoff EC steadily climbs up, then you don't want that plant to get past about 6 or 7, past the point of salt shock or stress. You want to start bringing the EC down slowly of what you deliver and monitor the runoff of your plants. As that runoff starts to come down in accordance to how your delivery EC has come down, then you can say, okay, we're at 5.5 now, we're at 4.5 now. We can slowly ramp it either back up or stay where we're at to maintain that 4.5 runoff EC. Runoff ECs and pHs and volume measurements are one of the most important tools growers have to determine how much water they need to put down, what the correct EC you should be watering at that point of watering, and also what the pH is as far as in the pot and what you should be applying. Now, the same is true for pH when you want to change that. However, the way pH changes is a little bit different because there's something called buffers. Buffers are going to slow the change of your pH, things like bicarbonates, things like that. They're going to slow the change of pH. So depending on what you're putting down into your plants, you may or may not need more or less pH adjusters. So again, if your pH in your leachate is too low, say you're bringing it down into like the 5.5, 5.3 ranges, which is pretty common with acidified nutrients these days. If your pH in your root zone is dropping, you may want to increase the pH of what you're delivering or increase the buffering capacity by adding things like carbonates, bicarbonates, buffering agents. I've seen a lot of guys add dolomitic lime to their soils to increase that buffering capacity for a long time. So the pH is going to be a little bit more tricky when it comes to what is applied versus what comes down. There's also a lot of, especially in things like cocoa and soil, there's a lot of soil microbiology going on that can acidify the soil solution. That's not necessarily a bad thing. A lot of the times it's because things are being acidified and complexed and becoming plant available. So that's fine. As long as you're within those healthy root zone ranges of 3.0 to about 6 to 7.0 EC and about 5.4 to about 6.4 on your pH, then you have a good balance in your root zone as far as your EC and your nutrient delivery and your pH and your pH buffering ability. So now that we've talked about applying nutrients, measuring nutrients as they come out, and allowing that data to kind of tell us how to adjust our ECs and our pHs. Another thing that is very important to fertigation that I think a lot of people miss is speed of liquid delivery. So these bags right here are generally made for about 2 to more drippers. And the way that the coco is structured, it's a very fine coco. So it's gonna have a lot of surface area for water to adhere to. It's gonna be able to hold a lot of water in and of itself. What happens a lot of the times, especially in these types of coco blocks, is when they get hydrated, they're not hydrated through drippers, they're hydrated through a wand, or they're hydrated in a batch, things like that. And they're hydrated too quickly. When it comes to a media block like this, whether it's in the course of daily fertigation or during the course of hydrating the bag, it needs to be a very slow and steady delivery of water if you want to prevent things like channeling, if you want to prevent things like nutrient hotspots or accumulation points where the water will run off the coco and then go off the side, and that creates like a little accumulation point. You don't want any of that. You want this bag to be as homogeneous as possible when it comes to the water and nutrient content. So watering slowly using half gallon, third of a gallon per hour drippers is what we recommend for these types of high CEC substrates. When it comes to Rockwool, it's more about consistency in watering the block. With these, it's a lot of consistency and speed in watering the block. The way that especially a Rockwool Hugo cube works with the great surfactants that they put on the Rockwool itself. Those Grodan Hugo cubes, you know, you hit them in the top with water and the surfactant helps bring that water out. There's not really any surfactants in these coco bags or in a lot of soil. So what we want to do is make sure that that water, you know, rain falls very slowly, but it infiltrates all the way down. That's the concept we want. We don't want to apply all of the water we need as fast as possible. We actually want to apply all of the water we need in a very moderate and slow pace so that we know from the top down this is getting watered evenly. Huge thing. If you're hand watering right now, this is probably a good opportunity to start looking into drip systems. All you really need is a pump and a couple of emitters, and you can really dial in your water delivery, especially in media like coco coir. And another big question I get is, how do I even calculate how much water I should be putting down? Again, you could use that EC measurement and just kind of aim high and then see where your runoff is at with that slow delivery. If your runoff is high, obviously you got to bring it down. But if you've kind of run these types of media bags before and you know that this is going to be like a 2,000 mil per day bag, then you can calculate your nutrient usage, your water usage, just by multiplying that, 2,000 mils per day to however many days the cycle is going to be. And then you can go ahead and get your averages and then get your cost analysis like that. Drybacks. So one thing that we are asked a lot about is drybacks. How frequent should drybacks be? How hard of a dryback should we give our plants? The rule of thumb that I'm going to tell people at all times is for Stonewool, you don't want to dry those cubes back to less than about 40 to 35%. Ideally, you want to stay at 40. For coco bags, you want to basically be around the same, but a little bit lower. You can go to about 30 to 35 and still maintain plant health. Beyond the range of about 35 for Stonewool, you're starting to ruin the water holding capacity of the Stonewool. Regardless of brand or type, if you've saturated that Stonewool with a nutrient solution and you let it dry back too hard, the water holding capacity of that starts to degrade and it won't hold as much water as it initially did or it's supposed to. So that's a really big thing. Make sure that you do not over dry your Stonewool medias because that really denudes the performance, that really cuts down on the water holding capacity. Coco and soil, it's a little bit nicer. You have a little bit of a wider range to play with as far as drybacks. But again, you don't want to go beyond 35 because what happens is it becomes very hard to resaturate the bag evenly. Kind of like when you're rehydrating these bags, you have to have a very slow and steady, consistent water delivery. When you over dry these, the same applies. You need a longer period of watering to get these consistently back up. And at that point, what also happens is as the water either evaporates or it runs off or the plant uses it, the EC of your root zone starts to spike. So the electrical conductivity potential is just like how much salt is in that water. And as the water goes away, the salt starts to go up. So that can lead to spikes in your root zone EC, which can lead to a little bit of shock, basically stopping the plant growing that day until it can get more water. Because these plants can't use these nutrients without water. So if the plant has less water than the nutrients, it's not going to use the nutrients until it gets enough water to move those nutrients where it needs to within the plant. So drybacks are important. They get the oxygen to the roots. They get that good exchange of air in the roots. But dryback is one of those things where you don't want to go beyond a certain threshold. And of course, you don't want your root zones to be too wet. You don't want them to be always saturated. You want them to come below that 50% mark, either daily or between irrigation cycles, because that swing of dry and wet is really going to stimulate root growth, which stimulates shoot growth, which stimulates bigger, more vigorous plants. So having effective dryback is important, but making sure that you don't go too far on the dryback and making sure that you go back to full saturation with runoff after those dryback events is extremely important. So make sure that if you are drying your pots back, don't worry too much about the steering aspect. Worry more about making sure that the table is set for your plants by having that good fresh root zone soil solution in there. So this is a very important tool. These pH and EC meters are very important tools. Lysimeter readings, runoff readings are incredibly important and potent tools for growers to be able to get the metrics they need to know how to optimize water usage, fertilizer usage, and at the same time optimize plant health by not having them dry back too much or not having them stay too wet, stay too high or low on EC or pH. So when it comes to irrigation strategies, a lot of guys are going to talk about things like P1, P2, P0, P3, things like that. We understand that not everyone is capable in their building or facility or grow design to be able to do 20, 30 shots a day. You know, in a perfect world, you would have that saturation P1, you'd have that soil solution exchange P2, and then you'd have that controlled dryback P3. But say you're on a single Dosatron line, you have 4 sections you have to water, so basically that one Dosatron line is running all day to water those 4 sections. In those cases where you can't have the perfect irrigation strategy of a P1, 2, and 3, the most important things come back to what we discussed earlier, your runoff rates and how fast you deliver that water. If you can get the runoff that you're looking for in all of your sections with what you have, then that's fine. You don't need necessarily a P1, 2, 3. It doesn't need to be that intricate. The main points that you need to hit is there should be a dryback to at least about 50% of the media of that night, and then it should come back up to 100% saturation the next day, consistent 100% saturation with runoff, and then during the course of that day, it should come back down to under 50% until the next day. So as long as you're maintaining that dryback and full saturation cycling, so don't get hung up too much on irrigation strategies. Focus on irrigation key points that you need to take away from what you're doing, which is getting that runoff, modulating the EC and pH of your root zone by measuring that runoff. And you should be very successful. So now that we've talked a little bit about the best practices and little tips and hints on applying water, applying fertilizers, another big aspect of this entire watering your plants that is kind of overlooked is maintaining the irrigation system itself. So every table, every run of drip emitters, we generally recommend getting a 120 to 140 mesh disc filter on the table itself, just to ensure that we're increasing the life of our drippers by not having any particulates or biofilms go into those drip orifices. And it just keeps the system cleaner, and it's an easier point of maintenance than all of the drippers. However, one thing that I've seen in a lot of the cultivations that I've been in is there is not a set plan or schedule to clean and change those filters. A filter's only as good as how clean it is. It's only as the efficiency and the efficacy of it drops as soon as it starts to get clogged. So cleaning those filters weekly, inspecting the filters, having your crew say, oh, it was just a little bit of like precipitate dust, or oh, it was just a little bit of biofilm. Having that information is really going to help you determine whether or not you need to add a cleaning additive, whether you want to do an acid flush at the end of your cycle. All of the important maintenance aspects, you can't really determine which ones you need for sure unless you're gathering the data on what's happening during the course of your grow. So monitoring and changing your filters is very important. Having the filters there is, more important, I suppose. So make sure that you do have filters before all of your emitter stacks. And ideally, at certain sections throughout the plumbing or piping of your fertigation system, depending on how complex and how far your runs are, definitely want flush valves and filters within certain amounts of length, maybe like 200 feet, so that you know that anything that builds up in there gets caught before it goes to the next section. So having sections where you have filters and flush valves periodically really increases the ability for growers to maintain their irrigation equipment and not have to do a wide sweeping facility-wide thing. When it comes to maintaining and cleaning the irrigation system, there's a couple of kind of tried and true methods in the hydroponic or in like the nutrient fertigation delivery world. The biggest thing that's generally recommended is to do an acid flush. Now, an acid flush is going to take care of a few things. Mainly, it's going to break up any salt precipitates that have built in the lines, that have built in dripper orifices or membranes, that have built up even in the filters. It's going to break them up so that they flow out of the system and don't accumulate more precipitates and become little rocks. The other thing that it's going to do is help break up a little bit of the biofilms and disrupt any little ecosystems that might be growing in your fertigation and irrigation lines and system. That acid flush is going to kind of kill a lot of the stuff that's in there, in your irrigation systems, in your orifices, in your drip lines, and it's also going to push all of that out without having caustic chemicals kind of burn up the membranes. A lot of oxidizing chemicals can harm the membranes and drippers. That's why the first step that's recommended even by the drip irrigation manufacturers is an acid flush. Now, if you have a high biofilm problem, what you'd want to do is after that acid flush, you'd follow it up with an oxidizer, and then you'd follow that up with fresh water. You're going to want to do all of these flushing techniques when the plants are not in that room. Either the plants have been moved out of that room or that room is fallow and you can run just a blank irrigation cycle, because you're generally going to be running like a 2 to 3 pH solution when you do that acid flush. And that acid flush, like I said, it's recommended by most drip irrigation manufacturers as the first line of maintenance for a drip irrigation system, and we recommend it as well. So one tip that I like to recommend to a lot of people designing a new facility and designing a new fertigation system is having a freshwater flush valve or freshwater flush port, where in your entire irrigation system, if you wanted to, you can bypass the entire fertigation system and just do fresh water. It's even better if you can kind of slave it into each individual room or section that you're doing, because in a perfect world, what you could do is after a nutrient fertigation event, at the last fertigation event of the day, you basically just push a couple of mils of water through your drip emitters to displace that nutrient solution, removing a lot of the risks associated of creating precipitates or building biofilms in your drip emitters and your lines. So if you're designing a new facility, it's something to consider adding a freshwater flush into your drip irrigation system so that the last irrigation pulse of the day, assuming you can do these more sophisticated pulse irrigation strategies, so that last irrigation pulse is actually a freshwater pulse. And that just makes sure that all of your lines are clear and ready for the next day's fertigation, and you're not building up anything weird in your lines. So the tips that I just covered are some of the main talking points or the main important key points that I try to relay to a lot of the people that I've been working with, because I feel like if you just maintain the fundamentals and you understand that these basic practices are more important than all of the little steering or any of the kind of optimization practices that are popular these days, if you can just create a consistent, predictable, and programmable fertigation program, then that, covers a lot of the bases in making sure that your plants have all the nutrients and water that they need. Once the plants have all the nutrients and water that they need, at that point is when you should really consider maybe adding additives, maybe doing a little bit of plant steering depending on the stage of the plant. All of the additional things are secondary to a solid, good fertigation program with solid fundamentals. So I hope this information helped you guys out a lot. If you have any questions about any of this information, please reach out to us at GrowersHouse.com. Our commercial team can help you guys out, and our consultant team, our TCAs, can give you guys some pointers or help you guys design a good fertigation design of your own. So thanks for watching. This is Mike from Growers House. If you have any questions or comments, feel free to leave them in the comments as well, and I'll catch you on the next one. Keep growing.